Page 322, continuing lesson 2 on drawing inferences from data. If you look at example 4, Derek is writing a report on cell phone usage. He collects data from a random sample of 7th graders in his school and finds 16 out of 20 7th graders have cell phones. If there are 290 7th graders in his school, estimate the number of 7th graders who have cell phones. So we actually have some math we can do to work this out, and there's just going to be one answer, so maybe a little bit of a relief there, hopefully. What we can do for this problem, we can do a proportion, would be one way of doing this. So there's 16 out of 20 with cell phones. We're trying to find the number out of 290. Once we have that set up, we can try to find a pattern. So if you do 290 divided by 20 is 14.5. So, that would be one way we could go with, is looking for a pattern. This would be times 14.5 then. So if you do 16 times 14.5, then that should give you the answer that we want, which is 232. The other option you have is what the book's doing as another way. You could say they're dividing, variables being divided by 290, so let's multiply by 290 on both sides. Okay, obviously, if I wasn't using a calculator, that would be a way of working that out maybe. And then these we would have to multiply together. The book kind of skipped over that step, but if you did it this way, so you'd have 16 times 290 is 4,640 over 20. And then if you divide that out, then you should get 232. So once you have the proportions set up, maybe different ways of working that out. Another way you could work this out is you could say, well, if 16 out of 20 have cell phones, if you take 16 divided by 20, you get 0.8, that's as a decimal. A percentage would be 80%. So basically that's saying 80%. Okay, so really we could say 80% of the students, or 80% of the total, have cell phones. So we could just take 0.8 times 290. That gives us 80% of the students, and we would get the same answer that way also. So it's kind of just whatever way out of those options that you want to work this out. So if we look at the try it, we've got a similar problem here. For his report, Derek also collects data from a random sample of 8th graders, finds 18 out of 20 8th graders have cell phones. If there are 310 8th graders in his school, estimate the number of 8th graders who have cell phones. So if you want to do a proportion on this, there's 18 out of 20, and we're trying to find the number out of 310. So one option, especially if we didn't have a calculator, we could say, well, they're dividing by 310. I'm going to multiply by 310 on both sides, which is like 310 over 1. On the right side, those will cancel. On the left side, if you work that out, would be 5,580 over 20. And then when you divide that, you should get 279. So 279 eighth graders with cell phones. Again, another option, you're just dividing it out. 18 divided by 20. That would be 9/10, and then you could do 9/10 times 310. Another option, third option, would be looking for a pattern. Pattern, if you do 310 divided by 20, would be 15.5. So if you multiply 18 times 15.5, that would get you the answer here as well. And then one thing you can do once you get your answer, just to make sure that you have the right answer, is if you put your answer back into your proportion, if you did a proportion, you can check your answer by seeing if these fractions are equal. How can we see if they're equal? Well, we could just divide them out. If we have a calculator especially, this would be a quick process. 18 divided by 20 is 9/10, and then if you do 279 divided by 310, you should also get 9/10. If they both come out the same, we know we've got the right answer. If they don't come out the same, we know we made a mistake somewhere. On the key concept, it talks about analyzing data and drawing inferences. So we talked about this last year, but just a little refresher. Measures of center, mean and median are measures of center. They give us kind of an idea of the center of the numbers. Measure of variability. One measure of variability is the range, and those can be used to analyze the data. So just a refresher, the range is the difference between the highest and the lowest numbers. So if you take the highest number minus the lowest number, gives you the range, and you can see they did that over here. This is actually the same exact dot plot that they used. Oh, nope, they changed the numbers a little bit. Well, it's the same as on example 2, it looks like, so not going to really talk about that anymore than what I already have. So number 1 on the do you understand, how can inferences be drawn about a population from data gathered from samples? So different ways we can do this, but one option is we could make a line plot or a box plot and look for patterns and trends, or we could use mean, median, and range to make inferences. Number 2, why can you use a random sample to make an inference? So we could say that a random sample is likely to be representative of the entire population. Number 3, Darren surveyed a random sample of 10 students from his science class about their favorite types of TV shows. 5 students like detective shows, 4 like comedy shows, 1 likes game shows. Darren concluded that the most popular type of TV show among students in his school is likely detective shows. Explain why Darren's inference is not valid. So there's a couple ways we could answer this, why this isn't valid. One is that it's only based on students in a science class, so just in one class. It doesn't matter what the class is. It happens to be science, but it could be math or history or whatever. If we only ask people in one class, that's not going to be a random sample of everybody. Also, it might not be representative of the opinions of the entire population. Another thing we could say is that maybe he didn't ask enough people. He only asked 10 people, and we don't know the size of the school, but he might need a larger sample besides that. Number 4, how can you use proportional reasoning to make an estimate about a population using data from a sample? Okay, pretty straightforward. You can write and solve a proportion. Number 5, in a carnival game, players get 5 chances to throw a basketball through a hoop. The dot plot shows the number of baskets made by 20 different players. Make an inference by looking at the shape of the data. So different ways we could answer this, but we might notice the cluster there, and then by that we could say that if we count them up, there's actually more than half of the people that made between 2 and 4 baskets. We could also talk about, the least amount that anybody made was 0 baskets. The most anybody made was 5 baskets. We could actually work out, which actually we're going to get into on the next part. We could find the mean. On part B, we're going to actually find the median. Oh, actually, we're finding both of them, sorry, on part B. So that would be helpful information as well that we could make inferences about. So part B, they're wanting us to find the median and the mean and figure out if they support our inference. So if you look at the numbers, they told us in the problem there were 20 numbers, which means we're going to have 2 middle numbers. If you think about 20, if you split it in half, you get 10. 10 and 10, but that doesn't leave anything in the middle. So what we want is 8 on each side. Sorry, 9 on each side. And then that would give us 2 middle numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So either those 2 or the bottom 2. It doesn't matter whether you start at the top or the bottom. Both middle numbers are going to be 3. So if you average out 3 and 3, you get 3. So the median here would be 3. And then if we figure out the mean, for the mean we need to add all those numbers together, which would be 54. And if you do 54 divided by 20, would be 2 7/10, 2.7. Rather than just adding 0 plus 0 plus 1 plus 1 plus 1 and so on, you can use multiplication, like we've got 4 3s, so you could say 3 times 4 and 4 times 4 and 5 times 3 and so on to make that quicker. Okay, but again, the mean is 2.7. The median we said was 3. And both of those support our inference because they're pretty close to 3, and we said people were going to make around 2 to 4 baskets, and 3's right in the middle of 2 and 4. So it looks like we did have a good inference with what we did for part A. So if we look at number 6, it says in the dot plot 3 out of 20 players made all 5 baskets. Based on this data, about how many players out of 300 will make all 5 baskets? So again, different ways you could do this. One option would be to do a proportion. So proportion for this, we could have 3 over 20 equals x over 300, or if you picked a different letter, that's fine. And then we're going to try to solve this. So we could try to find a pattern here. 300 divided by 20 is 15. So 20 times 15 is 300. If these are equal, multiply the numerator by 15 also, and then that would be 45. So we'd expect about 45 people to make all 5 baskets. And this could be important because maybe this is at a carnival that they're trying to decide how many prizes they need. So maybe they have so many people shoot the baskets, and then they kind of figure out, you know, maybe we need about this many prizes. And that way they're not like way over ordering, but then that way they're not running out of prizes either, hopefully. And finally, number 7. Manager of a box office gathered data from 2 different ticket windows where tickets to a music concert were being sold. Does the data shown in the box plots below support the inference that most of the tickets sold were about $40? Most of the tickets sold were about $40. And if you look at this, the answer is going to be no. Half the tickets sold from window 1 were between $30 and $73. Half the tickets sold from window 2 were between $38 and $73. Both windows 1 and 2 show the median ticket prices higher than $40. So the median's higher than 40. The one median's 50, the other one's 60. So that means even half of the tickets are more than that. And that's kind of like an average of, you know, where the middle of those is. So it looks like they are actually more expensive than the $40.